Welcome to Natalia Teaches. In this video, we're going to be looking at some homework examples of sets and subsets. Question 1. Determine the set A whose elements are all multiples of both 2 and 3 and that are less than 25 but greater than 5. So, we're going to be between 5 and 25 and multiples of 2 and 3. So, 6 is a multiple of both 2 and 3. 7 is not a multiple of either. 8 is only a multiple of 2. 9 is only a multiple of 3. 10 is a multiple of 2 only. 11 is a multiple of neither. 12 is a multiple of both 2 and 3. 13 is neither. 14 is 2. 15 is 3. 16 is 2. 17 is neither. 18 is both. 19 is neither. 20 is 2. 21 is 3. 22 is 2. 23 is neither. And 24 is both. So our set A would look like this. Question 2. If set A is all letters of the alphabet, find set V whose elements are all vowels. So V equals an empty curly brace, and the vowels are A, E, I, O, and U. So that is our answer. And you might be thinking that you've only ever seen numbers in a set, but anything can be in a set. It's just a group of common elements. Question 3. Find set P if P equals all prime numbers less than 15. A prime number is a number that can only be divided by 1 and itself. Let's write P equals an empty curly brace. 1 is not a prime number because it can be divided by itself, but then divided by 1 is the exact same thing. So it's not a prime number. 2 is a prime number because it can only be divided by 1 and itself. 3 is also a prime number. 4 can be divided by 2, so it's not prime. 5 is a prime number. 6 can be divided by 3 and 2, so that's not a prime number. 7 is. 8 can be divided by 2 and 4, so it's not. 9 can be divided by 3, so it's not. 10 can be divided by 5 and 2. 11 is a prime number. 12 can be divided by 6 and 2. 13 is a prime number. 14 can be divided by 7 and 2. And it's less than 15, so we actually don't need a comma there. And this is the set. Question 4. For exercises 4 and 5, let C equal pink, blue, purple, and orange. And let F be a subset of C and S be a subset of C. Determine set F whose elements are 4-letter words in C. So F equals, and we only want the 4-letter words, so pink and blue. We know that this is indeed a subset of C because all the elements of F are also in C, but not all of the elements in C are in F. Question 5. Determine set S whose elements are 6-letter words in C. So S equals curly brace. The 6-letter words are purple and orange. So our set will look like this. And it is indeed a subset of C because all the elements of S are also in C, but not all the elements of C are in S. Question 6. For exercises 6 and 7, let E equal all even numbers and F equal 2, 10, and 16. Explain whether F is a subset of E. For F to be a subset of E, all the elements in F have to also be in E. So we need to determine if all these numbers are even. 2 is even, 10 is even, and 16 is even. So F is a subset of E because all the numbers are even. Well, the elements in the set. Question 7. List all the subsets of F. So the first subset is always the empty set. The second set will be just single numbers, so 2, 10, 16, and then we'll do two numbers, so 2 and 10. My curly braces are not very good, but that's okay. 2 and 16, and then 10 and 16. And then you always include the whole set. So another subset of F would be 2, 10, and 16. Question 8. For exercises 8 and 9, let A equal, it's missing a little bracket there, 1, A, 7, B, and 11, and B equal 1, 3, 5, and 7. Explain whether B is a subset of A. In order for B to be a subset, it has to contain elements that are all found in A. So 1 is found in A. 3 is not found in A, though. So we don't even have to continue. We know that B is not a subset of A because elements 3, and 5 are not in A. Question 9. List all subsets of B. So we always start with the empty set. Remember, that can also be written like this. Then we do single numbers, so 1, 3, 5, 7, and then we do two numbers, so 1 and 3, 1 and 5, 1 and 7, 3 and 5, 3 and 7, and 5 and 7. Then we do three numbers, so 1, 3, and 5, 1, 3, and 7, 1, 5, 7, and 3, 5, 7. Then you never want to forget the subset with all of the elements in the set. Question 10. Let C equal all consonants preceding F. List set C and all of its subsets. So consonants are just the letters that aren't vowels, and preceding means before F in alphabetical order. So C equals, we start with A, but that's a vowel, so we don't put it in the set. B, C, D. E is a vowel, so F, but it says preceding F, so we don't actually include F. And our whole set is just B, C, and D. Then the subsets of C, we start with the empty set. Then we do single letters, so B, C, and D. Then 2, B and C, B and D, and C and D. Then we do the whole set, B, C, D. Question 11. Let A equal all real numbers y such that y equals 3x plus 1. List the members of set A if x is an element of 0, 1, 2, 3. So A equals, and then we'll do an open curly brace. If x is each of these numbers, then we'll just plug each one in. So y equals 3 times 0 plus 1. This would be 0 plus 1, or 1. So our first one is 1. If we plug in 1 here, 3 times 1 is 3 plus 1 equals 4. Plug in 2, we get 3 times 2 is 6, plus 1 equals 7. Then 3 times 3 equals 9, plus 1 equals 10. And this is all the elements of set A. Question 12. Let n equal 1, 3, 5, and 7, and O equal all odd numbers less than 15 but greater than 5. Explain whether n equals O. So we have the numbers between 5 and 15 that are odd. So right off the bat, we can tell that 1 is not between 5 and 15. Neither is 3. Neither is 5 because it's greater than 5. And 7 is the only one that actually fits. So n does not equal O because it includes odd numbers not between 5 and 15.